Our next problem deals with several different properties of functions. It says find the range, intervals of increasing and decreasing, and local and absolute minimums and maximums of the given function. Okay, here we're given a rational function. Now at this point we should be able to graph that by hand and figure a lot of those different properties out, okay, without the calculator. Okay, but this is a calculator problem because we're going to need the technology to actually give us the whole picture here. Okay, so first step is going to be to graph that function out. We'll just plug it into our y equals screen. So we'll go 5x divided by, and the trick here is anytime we have more than one thing happening in a denominator, we need parentheses around it. So we'll say parenthesis x squared plus 1. Okay, graph that, we'll see what we end up with. Okay, and something we've seen similar before. Now the first thing I want to do is figure out with this graph what the turning points are, what its minimums and maximums are. So for that we'll go second calc. Option 3 and 4 are mins and maxes. I'm just going to start on the left with the minimum. We'll go enter. Okay, for a minimum I need a left bound as I need to scroll past that min on the left. Right bound will go past it on the right. And then for a guess we'll get as close as we can to it. Okay, it looks like we have a minimum at 0.9 repeating, so we'll say -1, -2.5. And the graph looks to be symmetric, but we'll check out where this is anyways. We'll go option 4 for maximum. Left bound, right bound. We'll take a guess. And we'll end up with a maximum at 1, 2.5. So we can start off by naming our minimums and maximums. We could say we have an absolute minimum at -1, -2.5. Okay, so that's a x and y coordinate actually to describe our mins and maxes. And I'd say it's an absolute minimum because there's no point on the graph that goes below it. It's the lowest our graph goes for a y direction. We can say we have an absolute maximum as well at +1, +2.5. Because again, that's the highest my graph gets. There's no y values above that maximum. Okay, next thing we can talk about is the range of the function. And remember, with range, we're talking about y values. Okay, so we want to describe all the possible y values this graph uses, okay, once the x's are used. Here it looks like our graph tops out at this maximum and bottoms out at the minimum. Okay, all the y values in between are going to get used. So we'll say its range runs from -2.5 to 2.5. Okay, again, we're taking the lowest and the highest y values for that range. Okay, last thing we want to talk about was the intervals of increasing and decreasing. So we'll say increasing. And then also we're going to look at decreasing. And these are going to be made up of x values. Okay, as I move from left to right on my graph, as x goes up, it looks like our graph starts off by decreasing. Okay, from x equals -infinity on the left to x equals -1. And again, that's just the x value for my first minimum. So we're decreasing from -infinity to -1. And then union, it also looks like we decrease from this maximum, okay, on down towards the x-axis as we go to the right. So we'd say it's also decreasing from 1 to infinity. Okay, and then in between where it's increasing and where it's decreasing, the graph increases between my minimum and my maximum. Okay, so I'd say it's increasing from x value to x value, increasing from -1 to 1. Okay, so there's one example of this type of problem. Final time, you're going to see some different type of graph, but same idea here. Start off with the mins and maxes. Okay, determine if they're absolute or local. Okay, use them to determine your range, which is going to be the y values the graph uses. And then from there, okay, we can determine the increasing and decreasing intervals based on the x values.